Based on this generation of reliable turbines that should unlock a significant savings in the emissions these aircraft create and the economics that enables from a safety perspective then to feed back into the product with safety technology. So we'll let the team introduce themselves. So Richard, go first.
Hi, yeah, thanks David. I'm Richard Packe, so I'm the Managing Director of Heli Limited and the COO of BEA. So we operate helicopters and aeroplanes, public transport, pipeline surveillance operations, huge maintenance organisation, training. We pretty much do everything in the GA world with helicopters, and the Robinson being the primary brand that we use. So we do quite a lot of pipeline surveillance, which many of you may know what that is, but it's essentially you have gas and fuel pipelines buried about 3 feet underground. Most people don't know where they are. We do, and we have to fly above them at about 600 to 800 feet above ground level. And we've got a crew of people flying across about 9,000 kilometers of them every fortnight to stop everyone out there from digging them up, blowing themselves up, whatever they want to do when they're doing their building work. So given the different terrains we fly across, open countryside, over cities, the aircraft we choose is very important, but of course the emissions we create in doing it whilst working for many major energy companies, people who are signed up to IOGP, those companies who hire us to do this work are always asking these, and sometimes very difficult questions about what the emissions are for these aircraft.
Thanks, Richard. Yeah, we'll talk more on the topic of pipeline inspection, infrastructure inspection, and how that has to be addressed both on a sustainability front and on the economics. And of course, we talk a lot about that safety is table stakes for the product that we produce. And so the way we look at it is there are way more efficient ways to do the mission, and we'll share more about how that process evolves. So now, David, you can share some about the work you guys do.
Yeah, thank you very much. First, thanks to Robinson Helicopter Company, to David Smith for the invitation for talking here for this very important topic about more sustainability, less pollution with single engine helicopter missions. My name is David Pitterle. I'm from B&B Helitrade, Austria. We are a long time dealer for Robinson Helicopter Company. So far we sold more than 270 new Robinson helicopters and many more used ones. I myself have been flying helicopters for about 20 years. I'm a flight instructor and flight examiner as well. And furthermore, I'm working as a safety manager and compliance monitoring manager. We are 100% committed to the all-new R88. I think there is much space, even in Europe, where we have very restrictive laws and rules. I think there's much space. We have zero worries. We are only pure optimism about the 88, and I think further on we will talk about the suitable missions for the 88 and for other single-engine helicopters.
Yeah, and I think that's a good point. One of the ideas when we were formulating the product was that there's a need for aircraft that make less environmental impact, but provide the same features and technical performance of last generation's twin-engine aircraft. And so it was a deliberate effort to find a reliable engine, one that can hold up to the safety standards of commercial operations and in difficult areas. So, and I'll turn it over to Richard to talk a little bit about the pipeline inspection side can have restrictions on how you operate and where you can operate, but it has to operate in some very congested areas, some challenging places. And maybe talk a little bit about the migration of some of your customers from last generation twins into today's modern singles, and talk about what their thinking was on it and how that factored into their selection.
Sure. So in terms of the operation we do with the pipeline surveillance, we've historically had a suite of aircraft operating, whether it was an R44-66, which we introduced to the operation in the UK, or AS355s, EC135s as they were back then, which we're flying across actually the twins are often flying across the easiest terrain, but it was driven by the customer. It was the customer who was saying to us, fly in a twin please, because based on the safety data we had from a while back, that's what the thing was that we wanted to do. And moving forwards is always the pressure, both from an emissions point of view and a cost point of view, because our customers, as I said, I won't name the companies, but IOGP subscribers are looking for reduced costs, reduced emissions, but safety upgrades, which in reality for most aircraft is you never get all three. we were able to put the R66 to them. And interestingly, one of the reasons why the twin was on the job in the first place was because it was promoted by the pilots who were flying on the pipelines, and they decided they wanted to fly in a bigger aircraft with 2 engines, etc. However, in our instance, all of our flight crews who are flying a lot of flights all over the UK in these aircraft were asking me, can we put forward the R66? We want to fly in the R66. And so when we put it to these companies, they did their own safety analysis of the product. They looked at engine reliability data, which is unrivaled. It's amazing on the 66. So many, how many hours have we got?
2.3 million flight hours nearly, no engine failures in service. So certainly plays a role in those analysis for sure.
It certainly was the starting point, but then what they were able to look at were the various pieces of equipment we could offer to them to enhance safety for the areas that actually they're looking at. They don't view the engine reliability as one of the top 10 risks when flying around in our operations. There are other things, and the equipment that we can put on board a 66 now, which at the same time is cost effective and still provide a reduction in cost to the customer, meant that they were very happy because the 66 has its the fuel tanks are crashworthy, the seats are shock absorbent, you can get H-tours, you can get cockpit camera, you can get your flight data monitoring system going with the 66 very, very easily. And all of the bird-proof windscreen was another fundamental upgrade for them as far as they were concerned. So put all these together and tell them that you can do this, your flight crews want to do it, it's going to be a safety increase and you're going to have less than half emissions. That's really how we moved some major companies from the Twin Squirrels and EC135 work to the R66.
Yeah, I think this is a compelling example of where folks closest to the topic of reducing emissions and responding to the need for improved environmental impact did the hard work. And I got to see some of the work that Richard's team had done to help in collaboration for this, one of the big conversions, and very thorough analysis and very rigorous on the dimensions of safety, the economic side and the emission side. And ultimately, that was before we even added the features that Richard mentioned on safety enhancements. And I do think when you're trading these, you have a turbine engine over here, an extra one, and you have a pile of incredible safety technology that addresses the top 10 drivers of accidents really are issues in IMC, controlled flight into terrain, the sorts of things that we are addressing, as our primary drivers at Robinson. This morning, we signed an agreement with Lake Fusion Technologies that's building advanced LiDAR detection systems for wires and for obstructions near the ground. And that's still a significant killer in our fleets, and something that if you have to make these decisions around weight and performance, a twin engine application can be the right answer for certain types of emissions and exposure, but for our purposes in a lot of Central Europe, maybe not required. So maybe David, talk a little bit about the emissions that you guys carry in the single engine space that would be easier if the regulations were more open, but how would that affect emissions and operations, maybe even in flight paths? Would it be, if it's more direct to fly over a congested area, but the restrictions route you a longer way, of course you're producing more emissions en route,
Yeah, sure. As I said before, the European law, the regulation for air operation 965 of 2012, which laid down all the rules for air operations. It's very huge. There's more than 2,500 pages, and it's very restrictive in a way, and it's very, very precise. And there are plenty of missions you can do with single-engine helicopters actually now, like firefighting, like axle sling load, like transporting cargo inside and passengers, but only overhead, non-congested hostile environments. And you're not allowed to land on elevated helipads with single-engine helicopters. So to come back to your questions, of course you always need to plan if you want to go from A to B. Most of the time, it depends on the environment. Not the shortest track is the track you can fly, and because you always have to have forced landing sites available for single-engine helicopters. But as you told before, we have nowadays the R66 since 15 years in service with zero engine failures. That means for me the technique is ready, the engines are reliable, the aircrafts are very, very reliable altogether. So we need carefully analyze each aircraft per aircraft, each model, if it is suitable for more single-engine helicopter missions. Like we're doing this for the Catapult H305. For all Europeans, they really know this part very well. We need to have a very low rate of in-flight shutdowns for single-engine helicopters. Maybe we can push this forward to get more space into single-engine helicopter missions. I think it's one of our goals to have single-engine helicopters deployed in maybe 5-6 years. For health missions too,
yes,
and for passenger transport missions over congested hostile environments, because nowadays single-engine helicopters are as safe as twin-engine helicopters, but you save money, you save a lot of pollution and carbon, you save complexity, and you save weight. All of them you could put in more safety technologies, as Robinson is already doing since many years. Richard talked before about all the safety enhancements, and I think there's all ways you can do. You can make the single-engine helicopter aviation much more safer, and on the other hand, you could save pollution, carbon, because climate change and environmental pollution is given such a high priority here in Central Europe. And I think we operators and the manufacturer should address this. And it's more or less an easy calculation. If you use 2 engines instead of only 1 engine,
right,
you have 50 to 60%. It depends on the mission, on the helicopter variant. More pollution.
Right.
And that's a big issue. You can save all of this if you use only a single engine, a single reliable engine helicopter. And I think we are on the right terrain now.
Yeah, so one of the things that I'm interested in getting the perspective from the UKCAA and a little bit from EASA about what do we think the barriers are in getting the equation and the regulators to understand there's a pressure on emissions and a pressure on sustainability, and at the same time there is a historical precedent around safety that needs to be changed, needs to be converted. But how do we see those evolving over the next several years? And part of it, obviously, with a product launch coming with a very reliable engine, one of the most reliable engines in the world in the R88. The Ariel family has so many hours and significant performance. We feel confident that this is going to be a really good entry. What do we think needs to change in the regulatory space for the UKCAA? And then they'll let David talk about the EASA side. So
that's a good question. I think they've already done it in they've addressed the single engine in the fixed wing world, and we operate the SETIMC fixed wing public transport operation. We have the UK approval, but we were the first in Europe at the time. So we've been on it from the ground level. And basically, let's flush all the data out into the open. That's what they did. A study was done by Kinetic, who looked at the acceptable safety rate that we already have with twin engine fixed wing at the time.
It was a decade ago, roughly, when you guys did
about a decade ago,
yeah.
And since then, they quantified it. We were able to quantify it scientifically, and then say, right, if you can match that with a single engine, then it opens up those operations. And now let's talk about equipment fit, because that's the next question people, especially flight crews, will ask. Say, well, okay, the engine's one discussion, but if you're not worried about that, what about what's on board? What about stability? What about all this? And that's what's so great about the future with the 66 and the 88, is that we see it having all these things on board and more. So it's a big enhancement, and I think at that point there's not going to be a hurdle. So I really do think that the best way in a regulatory way is to get a study done as soon as we can to quantify and flush it out into the open.
And that was an EASA position paper as well on the SET methods for fixed wing IMC.
Yeah.
Do we feel like the rotorcraft community is going to have to go through some education even around that? Because you straddle between fixed wing and rotary.
Yeah.
Do you feel like the rotary is going to take more time, and we need to be helping drive working groups to help change this? Is that something that's needed?
Absolutely. I think we need to do both and get started as soon as possible. But I think it helps if you've got experience in one to bring across the methodology to the other. Because it all makes complete sense to us, which is why we decided to do it.
David, do you see that in some of the regions that you operate in, there are actually some pretty active local national air authorities? Do you see some regions that support already broader use of single engines? And
it's very difficult. It's a difficult question.
Yeah.
I think in Central Europe it's quite difficult. with the national regulations because they are following the EASA rules very strictly.
Okay.
Very strictly. But only a week ago, I've looked into the newest annual safety review of the EASA 2025, and I recognized in the category of CAT, commercial air transport emissions, the highest rate of serious accidents and incidents are caused in HEMS missions and not in passenger transport missions, which are mostly done by single and twin engine. And as we all know, HEMS missions in Europe basically have to be done by twin engines. So what I recognized is it's not the number of engines which are critical, the mission is the critical part.
Absolutely, and I think this is one of the areas that we aim to address through, we're blessed to be in a time when there's a lot of technology advancements that can go directly after the things that lead to accidents. So the HEMS missions, for example, a lot of times confined area landings, difficult environments that can drive the human factors to be a very difficult, either high workload or degraded visual environments. Technology can support that and can make it much, much easier. So I'll hold it closer to my mouth, sorry. But I do think there's an opportunity for us on the backs of the new technology that's coming, where we can fit it into the aircraft and it can be offsetting to you remove a second engine and provide then a package of technology that addresses those biggest hitters. And maybe that's a case we can make to expand the operations and even into HEMS. And in the US, there's single engine HEMS all over. That's the primary use case for HEMS in the US is single engine applications. And then similarly, I think about our Brazilian market where we have thousands of flights a day that are primarily singles, and they're flying air tourism and air charter right over congested cities and roads. And we don't see those aircraft having challenges with the engine. We do see challenges, many of them as well, IMC, many of them challenges in maintenance, and maintenance certainly is another topic that is better with less engines because less things can go wrong. So ultimately I think those things are certainly things that I feel are tailwinds for us. What are going to be the biggest headwinds, do you think? And you know, we asked this question to our dealers, and I'll spare those who are there know, they think there's a strong lobby that pushes to maintain a twin engine approach to the operations. But besides sort of parochial interests, where do we think the actual pushback is going to be in the operators, for example? You had probably some folks in the energy production industry that were anchored in their belief that twins were better. So how did you go about neutralizing that? And is there a guide you can give us, you know?
Well, yeah, I mean, in order to do that, we just had to engage with them and talk to them about what the concerns were. Discuss them, bring them out to the open, nothing to hide from. And once we had all the information, the data, obviously David and RHC extremely helpful in getting accurate information to them. Once they had that confidence, actually they then believed in the data, and that's what opened the doorway. So in short, that's what it is.
One of the areas that we're going to also work on, a big thing for us, we've been getting increasingly active in engagement with the insurance industry too, to make sure that they support this approach, that in their world, the risks obviously are something that they can have data to back up decisions that migrate away from, say, older fleet mix aircraft that were built with last generation twin architectures. And I think we kind of talked about in our kind of pre-discussion that really there's no question that an older generation twin versus a newer generation single, which one is going to be a safer operational tool for even congested areas or high-risk missions. And I think our argument is that things like insurance can be a layer that needs education as well. We're going to do some of the heavy lifting to walk them through both our existing fleet data, introduce them more to what the 66 has had these last 15 years, and then spend some time with them on the enhancements we've added to the aircraft for new entries like the R88. So insurance is certainly a challenge. Did you guys see? Yeah, so we are at time. I have a great stage team. So really appreciate you guys joining us today for this topic. We feel like the most effective way for us to drive emissions down in economics and broaden the access to vertical lift is going to be to reduce the amount of engines required to keep the aircraft flying. And so that's one of the reasons why you've seen us unveil the R88. Come see it in our booth if you have a chance. Thank you.
Thank you.
Thank you.